Hello, good morning friends. Today we are going to learn vector spaces, which is our model number 2. Now the today's topic is Cauchy Schwartz inequality. Now in this lecture what we'll learn, we'll start with dot product. There are two different forms of dot product. One is component wise multiplication and second is the definition of with the help of cost. So that we'll learn. We'll solve examples on dot product and then we'll prove our main thing, that is Cauchy Schwartz inequality, and then we'll solve examples on Cauchy Schwartz inequality. So first, what do you mean by dot product? This dot product is also called as inner product in terms of components, because we have some components are there, then we can multiply these components. And this dot product is also called as Euclidean inner product also. Now if u is equal to u1 comma u2 and v is equal to v1 comma v2 be any two vectors which are given, then how to find its dot product? So its dot product is nothing but u dot v, or the inner product is u dot v, and it is obtained by multiplying u dot v equal to u1 v1 plus u2 v2. That is, we are multiplying the elements of this u and this v element by element. This is for two dimensional, but suppose we have a vector u and v in three dimensional. Three dimensional means there are three components, that is u is equal to u1 u2 u3 and v equal to v1 v2 v3. Then what is their dot product? Then in that case the dot product is u1 v1 plus u2 v2 plus u3 v3. Now, or the second and main important definition of dot product which we use today is u dot v equal to norm u into norm v into cos theta. So this is a very important definition for today's lecture. So today we'll first solve example on this definition, that u dot v equal to norm u into norm v into cos theta. So first type of example they will ask you. First is example, they will give you some vectors and they will ask you to find out the angle between these two vectors. For example, find the angle between the vectors u equal to 2 minus 1 1 and v equal to 1 1 2. Now the method to solve this example, you already know the definition of dot product, right? The definition of dot product is u dot v equal to norm u into norm v into cos theta. So from this equation we can find out the value of cos theta. It's very easy to find. Yes, cos theta is equal to u dot v upon norm v into norm v by just simplification. And now if you put the value of this numerator here and the value of the denominator here, we'll get cos theta, and then by just taking the inverse of this we'll get the value of theta. Now u dot v, to find u dot v we have to use the definition of components, right? So 2 minus 1 1 into 1 1 2 divided by norm 4 plus 1 plus 1 into under root of 1 plus 1 plus 4. That is, after finding the dot product in the numerator we get 2 into 1 plus minus 1 into 1 plus 1 into 2 divided by root 6 into root 6, which is equal to 3 by 6 is equal to 1 by 2, or therefore cos theta is equal to 1 by 2, or you can say theta is equal to cos inverse of 1 by 2, and we know that cos inverse of 1 by 2 is pi by 3. So it's very simple example that how to find angle between two vectors, right? As you already familiar with u dot v, norm u, norm v, so this type of problems are very simple. So let us solve one more example of the same. Two vectors are given and we are trying to find out theta between this. So what are these two vectors? So here u equal to 6 to 4 and v is equal to 2 0 minus 3. Again the method is same. Now you stop your video for 1 or 2 minutes. You first solve this example yourself and then you can cross verify the solution which I have explained now. So we know u dot v equal to norm u into norm v into cos theta. So from this we can rearrange the equation to get cos theta. So cos theta is equal to u dot v upon norm u into norm v. And now we put the value of u and v here. U is 6 to 4 and v is equal to 2 0 minus 3 divided by under root of 36 plus 4 plus 16 divided by 4 plus 0 plus 9. And finding the dot product in the numerator, we'll get 6 into 2 plus 2 into 0 plus 4 into minus 3 divided by root of 56 into root of 13, that is 0 upon root 56 into root 13, that is 0. Therefore the value of cos theta is equal to 0, or you can say theta is equal to cos inverse of 0, and we know cos inverse of 0 is pi by 2 or 90 degree. So it's a very simple example. Now our main target, Cauchy Schwartz inequality. So what is the statement of Cauchy Schwartz inequality. What the Cauchy Schwartz inequality says, Cauchy Schwartz inequality in Rn, we are putting in a general, not for 2 or 3 vectors. So let us take u equal to u1, u2, un, and v is equal to v1, v2, vn, be any two vectors, where both the vectors have n elements, are any two vectors in Rn. Now, what is the statement then? What is the main part here? Cauchy Schwartz inequality states that u dot v, that is modulus of u dot v, is less than or equal to norm u into norm v. We have to prove this, and it's very simple to prove it. Now here, how to prove this? We know that u and v are any two vectors which are given in the example. So if we take u and v two any vectors and we try to find out the dot product by our second definition, that is u dot v is equal to u dot v equal to norm v into norm v into cos theta. This definition we already know. We solved examples also on that. Now if you observe carefully, what we want to prove? Modulus of u dot v is less than or equal to norm v into norm v. But we have u dot v equal to norm v into cos theta. So what is missing here in the definition? Modulus. So to prove this theorem, our next step is to take modulus on both sides. When we take modulus on both sides, what will get? Modulus of u dot v is equal to norm v into cos of theta. Now if you observe here, left hand side we are taking modulus, but in the right hand side I have written norm v into norm v as it is. This norm v into norm v I have written as it is because norm v is a positive, norm v is a positive, so their modulus is also positive, so no need to write modulus here. Yeah, for cos theta we are writing modulus here, so modulus of cos theta. So we got modulus of this, so left hand side we obtain as it is. But now we have inequality and there is no cos theta. So we have to remove this cos theta. How to remove this cos theta? What is the value of modulus of cos theta? Yes, correct. Modulus of cos theta is less than or equal to 1 always. So if you put the value of this cos theta here, that is less than or equal to 1, this equality becomes non-equality and therefore we will get our required inequality to modulus of u dot v is less than or equal to norm v into norm v. So in the next example, we'll find or we can prove that whether the vectors really satisfy the Cauchy Schwartz inequality. So examples of this type they will ask in the examination. Verify Cauchy Schwartz inequality for some vectors, and these vectors are, suppose u is equal to 3, 4, 5 and v is equal to 1, 3. Now to prove Cauchy Schwartz inequality means actually you have to put the value of u and v in Cauchy Schwartz inequality and prove that left hand side is equal to right hand side, or left hand side is less than or equal to right hand side. So we have to verify modulus of u dot v is less than or equal to norm v into norm v. Now u dot v is 4, 5 dot product with 1, 3. You are already familiar with how to find a dot product now. So u dot v is equal to 4 into 1 plus 5 into 3, which is equal to 4 plus 15, that is 19. So you got the value of u dot v is 19. So left hand side is modulus of 19 is 19. And since u is equal to 4, 5 and v is equal to 1, 3, which is given in the example itself, I will try to find out the norm of u. So what is the norm of u? Under root of 4 square is 16 plus 5 square is 25, that is root of 41. Similarly, norm of v is equal to 1 plus 9, that is root 10. Now, therefore, norm u into norm v is equal to root 41 into root 10 is equal to root of 410. That is, we got the value of right hand side of this Cauchy Schwartz inequality, that is u norm u into norm v is root 410. At the same time, we know the value of left hand side is 19. So what we can write? Therefore, we can write modulus of u dot v is 19 and norm u into norm v is equal to root of 410. And if you observe carefully, 19 is less than 410. That is, we can write modulus of u dot v equal to 19 less than or equal to norm u into norm v, which is root of 410. And why this is? Because 361 is less than 410. Actually, I am taking the square of 19 and square of 410. Taking square on both sides, we will get 361 less than 410. So it will become very easy to check whether it is really true or not. And therefore, Cauchy Schwartz inequality is verified. Now, similarly, we will solve one more example of the same type, but with 3 dimensions. So what I will suggest, again, you stop yourself and then try. What is the example? Here example is it. Verify Cauchy Schwartz inequality for u and v. So you try to solve it and then cross verify your answer. Now again we start with the same. We have to verify modulus of u dot v less than or equal to norm u into norm v which is our Cauchy Schwartz inequality. So again we'll try to find out the value of this left hand side and value of right hand side. So let us start to find the value of left hand side. So here u equal to 2 1 minus 3 and v is equal to 3 4 minus 2. So it is a dot product. Therefore u dot v equal to 2 into 3 plus 1 into 4 plus minus 3 into minus 2, which is equal to 6 plus 4 plus 6, that is 16. So therefore the value of left hand side, that is modulus of u dot v, is 16. So you got the value of this left hand side, that is modulus of u dot v, is 16. Now let us try to find out the value of this right hand side now, this one. So to get the value of right hand side, we write u equal to 2 1 minus 3. Therefore modulus of u equal to 2 square is 4 plus 1 plus 9, that is root 14, and v equal to 3 4 minus 2. Therefore modulus of, therefore norm of v equal to under root of 9 plus 16 plus 4, which is equal to root of 29. And therefore norm u into norm v is equal to root 14 into root 29, that is root of 406. That is the value of right hand side. Root of 406 is the value of right hand side of inequality, and root of and 16 is the left hand side of inequality. Therefore we observe from this that modulus of u dot v is equal to 16, which is less than root 406, but which is norm u into norm v, that is 256 is less than 406, and it clearly implies that left hand side is less than or equal to right hand side of this Cauchy Schwartz inequality. Therefore Cauchy Schwartz inequality is verified, and this completes our example. So now what we have learned today? So we have learned what is meant by dot product, that is the component wise dot product, and the second definition we have defined u dot v with the help of cos theta. So we got two different definitions of dot product now, and with the help of second definition of dot product we have solved two examples, that is find angle between the two vectors. If the vectors are given, whether it is a two-dimensional or three-dimensional, we can find out the value of theta. And then we have proved our main theory, that is Cauchy Schwartz inequality, that is modulus of u dot v is less than or equal to norm u into norm v. And then we have solved examples on Cauchy Schwartz inequality. If some vectors are given, how to prove that these vectors satisfy this Cauchy Schwartz inequality by finding left hand side and right hand side. Thank you.